Hi everyone, today we're going to study the parabola whose vertex at the origin that opens to the left. First, let us define the parabola. A parabola is a set of all points in a plane equidistant from a fixed point and fixed line in that plane. The fixed point is called the focus of the parabola, and the fixed line is called the directrix. Let us draw a parabola that opens to the left. Here we have a point and a line. Take note, intentionally we put the point on the left side and this line on the right. This fixed point is the focus, and the fixed line, which is vertical, is the directrix. Now, let us find some points that satisfy the condition of the parabola. The first point is the one between the focus and the directrix. Let us find two more points, and these are the points. Let us put four more points, and these are the points that satisfy the condition of the parabola. Let us connect these points with a smooth curve, so we have now the parabola. Intentionally, we put one point of the parabola in the origin, and that is 0, 0. Now, there is a line that passes through the focus perpendicular to the directrix, and that is called axis. This is the axis. In this example, the axis is also the x-axis. The intersection of the axis and the parabola is called vertex. This is the vertex. The chord drawn through the focus and perpendicular to the axis of the parabola is called latus rectum. This is the latus rectum. It connects two points of the parabola. This is now a parabola that opens to the left and vertex at the origin. We let A to be the distance between vertex and focus. It means to say the focus has the coordinates now negative A, 0. And the directrix has equation x equals A. We take one point of the parabola, say this point. We put this P with coordinates xy. And this point represents all the points of the parabola. We're going to take the distance of this moving point and the fixed point focus. We denote this as d sub 1. Also, we take the distance of this moving point away from the directrix. By definition of parabola, this d sub 1 is equal to d sub 2. Take note, d sub 1 is the distance between 2 points, so we use the formula for distance between 2 points. So we have now the big square root of this x minus the negative a, and the quantity is squared, plus the y minus 0, and this quantity is squared. For the right side, this is equal to d sub 2, and that is the distance from this point to the line. So we have here a minus x. Let us square both sides. So the left side now becomes x plus a. So this minus and negative a now plus a. And the quantity is squared plus y minus 0 is y, and this is squared, equals the right side a minus x is squared. Let us expand the squares, so the left side now becomes x squared plus 2ax plus a squared plus y squared, equals the right side is a squared minus 2ax plus x squared. We can see here this x squared and the other x squared on the right side can be cancelled out. Also, this a squared can be cancelled out with the a squared on the right. Now let us simplify further. This positive 2ax we will transpose to the right. So we have now y squared equals negative 2ax and now negative 2ax. Combining the terms of the right side, we have y squared equals negative 4ax. This is now the equation of parabola with vertex at origin and opens to the left. Now let us substitute x equals negative a to get the coordinates of endpoints of latus rectum. So this y squared equals negative 4ax now becomes y squared equals negative 4a times x, and the x now becomes negative a. This negative times negative becomes positive, and a times a is now a squared. So we have now y squared equals positive 4a squared. Let us take the square root of both sides. So we have the square root of y squared equals the square root of 4a squared. On the left side, this radical sign and the power 2 can cancel each other. So we have now y equals plus or minus 2a. So the endpoints of latus rectum are the points negative a, 2a, and negative a, negative 2a. This point here is the negative a, 2a, and this point here is the negative a, negative 2a. By this figure, we can see that the length of latus rectum equals 4a. We can see here that this 4a is familiar to our equation of parabola, and that is the coefficient of x. The only thing is it is positive. Let's have an example. Find the equation of the parabola with vertex at origin and focus in negative 5, 0. Sketch and discuss the graph. For our solution, we know that a is the distance between vertex and focus. And since the origin is the vertex and the focus is at negative 5, 0, it means a equals 5. From here, we can say that the parabola has the vertex at origin and opens to the left. Writing now the general equation of the parabola, this is now y squared equals negative 4ax. Let us substitute the value of a as 5 in the equation. So we have now y squared equals negative 4a, now negative 4 times 5 times x. So we will multiply this negative 4 by 5. We have now y squared equals negative 20x. This is now our answer. This is the equation of the parabola with vertex at origin and focus in -5, 0. Let us now sketch the graph. Using GeoGebra, this is now the parabola y squared equals -20x. Let us now discuss the graph. The vertex is at 0, 0. That is the origin. The focus is here, the -5, 0. The line directrix has the equation x equals 5. The length of latus rectum equals 20. That is the positive value of the coefficient of x. The endpoints of latus rectum are the points -5, 10 and the point -5, -10. This idea comes from the formula a plus or minus 2a. The axis is the x-axis itself and the equation is y equals 0. This is our final answer. I hope you learned something from this video. See you again next time.